Teams often set up a production-like environment, known as staging, where they test and validate new features before releasing them. Here's what a typical flow looks like. A developer sets up their local development environment where they start developing a new feature. Once they're happy with their changes locally, they deploy to a staging environment where the feature then gets reviewed by stakeholders. Once everyone is happy, you deploy to production. Now, while this flow works, it is far from ideal when you have several developers collaborating on the same project. That's because a staging environment can break. This could be due to a bad release or a bad database migration. It happens. And when that happens, well, the entire team is blocked and is unable to preview their changes. Now, another scenario is when a developer wants to test their changes in isolation and they don't want someone else's work to affect theirs. So what will happen is the entire team will also be unable to preview their changes throughout that period. And finally, this pattern kind of forces you into doing a big release, which includes several changes at once. So what happens is when you actually release and something goes wrong unexpectedly, and you're not sure what is the cause, well, you're going to have to undo all of your changes. Now, thankfully, a new pattern is becoming increasingly more popular in its preview environments. Rather than having a shared and fixed staging where all developers collaborate, you automatically provision a production-like environment for every new code change you want to introduce. This way, developers can build new features in parallel without affecting each other, and you can easily revert changes if something goes wrong. This enables you to ship new features faster and with more confidence. Now, a lot of deployment platforms are starting to support this flow out of the box by enabling you to set up an automatic Git integration. This way, you don't have to worry about maintaining and managing the necessary infrastructure for handling this type of flow. Here's an example. This is Neon's website. It's built using Next.js and is hosted on Vercel. Now, let's say I want to make a change. I want to update this banner to say, join us on March 29th for Developer Days number 2. So to do that, I have the project locally installed on my machine. I will first create a new Git branch, checkout, -b, and let's call it update banner text. And then I'll make my changes. So I'll go here, join us on March 29th for Developer Days. I'm going to do number 2. I will add everything. I will add a commit message and say update banner. And then I will push my changes. And now I can open a pull request. So let's create. And what's going to happen is I have Vercel bot here, which is creating a preview environment for me, or also they refer to them as preview deployments. And once that's done, I will have an isolated production-like environment where I can preview my changes before merging them. So this is going to take a few minutes to build and to set up. Now I can click on View Deployment, and I can preview my changes at the top. It says number 2. And this is hosted on a unique URL. So I can just share this with anyone. And once I get the green light that, my changes are good, I can just merge, which is awesome. Now this flow is great, but if you're building an app that is backed by a database, things can get a little bit tricky because you will need to provision a database for every pull request. And at the same time, this preview database, you will want to have production data in it so that it accurately reflects production. So to do that, you will most likely need to import data from an old backup, and depending on the size of your database, this can take a really long time. That's why teams just often skip this step altogether, and they just set up a shared database to be used by all previews. Now, this is not ideal because any change made to that preview database will affect all active previews. So say, for example, I'm working in a team and I want to make a change that drops a column in a table in the database. Well, when I apply my change, and any active preview will be using the old database schema. So they might be affected or essentially broken. So it's kind of like a bottleneck, and it's kind of like staging, but in disguise. Now, thankfully, it doesn't have to be this way, because today I'll show you how you can set up a database for every pull request using Vercel Neon, and GitHub Actions. So without further ado, let's get started. Neon is fully managed serverless Postgres. This means you don't have to pick a size for your database upfront, and it will automatically allocate resources to meet your database's workload. Now let's see what the experience looks like. So right now I'm in the Neon console. I have an account and I'm logged in, and I'm going to create a project. So I'll click on create a project. I'll call this project demo, and I'll choose Europe as my region. So immediately I have a connection string that I can use. And yeah, I have a running Postgres instance, which is awesome. Now, by default, when you create a project in Neon, you have a default Postgres cluster. And within this Postgres cluster, you can have many databases. And by default, a database gets automatically created, and it's called NeonDB. Now, this is important to know because it will help you understand Neon branching. Neon enables you to create copies of your project's Postgres cluster, where each copy is completely isolated from the other. Now, we refer to this process as branching, and well, each copy is called a branch. So by default, when you created the project, the default Postgres cluster is represented by a branch called main, and this is the primary branch. And whenever we want to create a copy, we're going to create a branch from another branch. In this case, we only have one, so it's going to be main. Now, before getting started, we don't have any tables right now, so I'm going to create a new table and add some data in it. And to do that, I'll go to the SQL editor, and I'm going to add this SQL query. So this query creates a new table called elements, and it has 3 columns. It has the element's name, an atomic number, and a symbol. So this table will contain a list of elements that are in the periodic table. And then what we're doing is we're inserting the first 10 elements that are in the periodic table in this elements table. And number 10, we have Neon, which is nice. So I'll click run, and it ran successfully. And I can check the data that got added by going to the tables page. I will see that I have an elements table, and I have 10 items. Now let's create a copy of this main branch. So I'll go to the branches page. As you can see, we only have one branch. This is the main branch, and it's the primary branch. And let's create a new branch. So I'll give this branch a name. Let's call it demo branch. And we need to select a parent. So this is kind of like the source and the branch that we're going to copy. And since we only have one, it's going to be main. Now, we have several options when it comes to which data we want included in this new branch, in this new copy. So we have head, which just means we're going to include all of the data up to the current point in time. So right now, when I click create a branch, I will just have all of the data. And we have another option, which is time. So this is different. It allows you to include all data up to a certain point in time in the past. So this could be within 7 days, and we plan on making this kind of like window configurable. But within 7 days, you can pick a point in time, and this new branch will include all the data up to that point. This is very useful if you want to restore your branch to a previous state. And then finally, we have LSN, which stands for long sequence number, which is a pointer in Postgres's write-ahead log. So this is even more specific than the time option if you want to revert a branch to a previous state. And finally, we have configure endpoints. So this is how we actually connect to a branch. Each branch right now has an associated compute endpoint, and this is how we have the connection string that we're going to use to connect to that branch. So let's click create. And yeah, immediately I have a connection string that I can use. And this is actually different than the main branch. So if I go back to the dashboard, you will see I have in the connection details widget, I have branch. I can choose between the main branch and the demo branch. So for the main branch, you can see it's called like EP falling mouse and then some numbers. When I choose the demo branch, it's different. It's like EP raspy pond. So each of these two branches are completely isolated. And this demo branch, if I actually go back to the tables page and I have the demo branch right here, you will see that I have the elements table with all of the data here. Now, to prove that these two branches are completely isolated from one another, let's go back to the SQL editor. We have the demo branch selected, and I'm going to add a different query. So now this just adds 10 more elements. And when I click run and I go back to the tables, you will see that, okay, I'm still on demo branch. I'll select elements. I now have 20 items in the elements table. And if I switch to the main branch, you'll see that I still have 10 items, which is awesome. Now, this process, branching, is very, very useful in our case, which is we want to create a database for each pull request. And we're going to see how to do that using Vercel and GitHub Actions. We can break down the flow into 3 phases. The first one is local development. You can use a Neon branch, or if you prefer, you can use a local Postgres instance. Once you're happy with your changes, which may or may not include database migrations, you're going to create a pull request. This will trigger a CI/CD workflow where you create a Neon branch and apply migrations to it. You'll then create a preview deployment on Vercel. If everything looks good and is working as expected, you're going to merge the pull request, which will trigger another CI/CD workflow that will deploy your app to production. During this workflow, you're going to apply the database migrations to the main branch, which includes your production database, and create a production deployment to Vercel. Finally, you're going to delete the old preview branch since you won't need it anymore. To see what this flow looks like, I have this demo app that displays the data coming from the elements table that we previously created. Now, this app is built using Next.js, Prisma, Neon, and is deployed to Vercel. And for our CI/CD pipeline for this project, we'll be using GitHub Actions, which are automated workflows that you define as code. And these workflows, they live in your project's repo. So the way it works is you have a .github folder, and inside it, you define the different workflows in YAML. So we have 2 workflows, deploy preview, and this workflow is responsible for creating a preview deployment for every pull request. And then we have a deploy production workflow, which runs whenever we push any commit to our main branch. So for example, if we have an open pull request and we merge, that should trigger this workflow. Now, before actually diving into the code, we need to set a bunch of secrets that will be used by these 2 workflows. And to do that, we need to go to the Actions Secrets page. And you can find this page by going to the repository settings, scrolling to the security section, and expanding the secrets and variables dropdown and choosing actions. And in this page, we specify the different secrets, and we have a bunch of them. So the first one is the database URL. This is the database connection string that will be used when we deploy our app to production. And then we have a direct database URL. And the difference between these two is that the direct database URL doesn't go through a connection pooler. It connects directly to the database. And this is required by Prisma Migrate to be able to reliably run migrations. So that's why we need the 2 connection strings. Next, we have the Neon API key and the Neon project ID. And we need the Neon API key to be able to programmatically create branches. So to find these 2 values, what you need to do is go to the account settings, pick developer settings, and then you can see the list of available API keys that you generated, or you can generate a new one. I already did it. I have a GitHub Action API key here. And for the project ID, what you need to do is go to projects, select your project, and then go to the project settings from the sidebar. And then you can see the project ID here. Now, the last 2 thing is we need a set of credentials, and these will be used when we're creating a branch. So here, for example, the credentials are my name, Mahmoud, this is the username, and then there's the password. So we also need to specify these 2 values as secrets so that when we create a new Neon branch, we will use them as the username and password. And finally, the last secret we set is the Vercel token. And this is needed so that we can trigger deployments from the GitHub action, and it's used to basically authenticate. And that's pretty much it. So for the Vercel token, you will find it in the account settings. So you go to settings, pick tokens from the sidebar, and then you create a new token. And whatever value you get here, you store it as a secret. And that's pretty much it for the secrets. Now let's actually do a deep dive around the workflow code. Let's start with the deploy preview workflow. Now, this workflow runs every time we create a pull request, and it does the following steps. So it runs a single job, and it has the following steps. So the first step is checkout. This enables the workflow to actually access the code that's in our repo. What we're then doing is getting the pull request SHA or SHA. This is a unique identifier for every Git commit. And we're getting it because we'll be using it as the branch name whenever we create a branch. And the reason we're doing this is after we merge a pull request, we want to clean up old unused database branches. And we will do that by getting them using this unique identifier. So that's why we're getting the pull request SHA here. And then in the step that's below it, what we're doing is we're creating a Neon branch. And this uses a GitHub action that the Neon team has created, and it takes the following arguments. So first, the project ID, and we're getting this value from the repository secrets. So this is the notation, $, double curly braces, and then secrets dot the secret name. And then we're passing the branch name, which we're getting from the previous step. That's why we're saying steps.get pull request SHA. This is the ID of the previous step. And then .outputs, which is the output of that previous step. And we're getting this value here. So because we're echoing the pull request SHA here, we're able to access it in the next step. Then what we're doing is running Prisma Migrate. So the way Prisma Migrate works, we're generating Prisma client, and then we're using Prisma Migrate deploy. And what happens is that Prisma Migrate looks inside the migrations folder, so it's Prisma/migrations, and then compares this migrations folder with the database URL. So in our case here, it's the Neon branch that we just created, and then we'll see, okay, do we have any pending migrations? Are there any migrations that we created as part of the pull request that haven't been applied to this branch that we just created? If the answer is no, then no pending migrations, then nothing happens during this step. If the answer is yes, then we apply the migrations to that newly created Neon branch. And that's how we'll be able to have a Neon branch that contains the latest changes, and we're testing these changes in isolation because, well, a branch doesn't affect any other branches on Neon. And then the final 4 steps here is we're deploying to Vercel. So first we're installing the CLI, we're pulling all of the environment variables, then we're building the project, and then we're deploying it. So you deploy it by doing Vercel deploy -- pre-built because we ran the build command beforehand. And then we're passing in the token as a CLI argument. And then finally, once all of this works, we comment on the pull request by showing the Vercel Preview URL. And we're getting this from the deploy step here. So we have deploy preview to Vercel, the output called preview URL, and that's how we're getting it here. And then we're also getting the Neon branch. So after we create the branch, we'll be able to see the URL here so that we can go to it if we want. So let's actually see this in action. I want to make a new change. So to do that, I will first, I'm on main, I will create a new branch, git branch to be precise, and let's call it update page layout. I want to change the layout of the table so that it has like a different style. So the way it works, I'll go to the page, and then here I have a class called grid calls 5. So let's change this to 4, for example. Then I will add all of my changes. So I'll get add dot, and then let's say the commit message is change calls number to 4. And then what I'll do is actually push my changes. So I need to set the upstream. Then what I'll do is just create a pull request, which will trigger this deploy preview workflow that we just saw. So now I will create, so I actually want this to be in my own fork. Okay, so now I'm going to create a new pull request and we'll see what happens. So the first thing you'll notice is that Vercel bot said one ignored deployment. And this is something that I forgot to mention, and I disabled the automatic preview deployments that are being created by Vercel because now we're triggering them using a GitHub action. This is to avoid having two preview builds happening at the same time for the same commit, which is unnecessary. And to do that, there is a guide that shows exactly how to do it. It's in the project's README. And all you need to do is in your Vercel project settings, you add that. So I added this command and it just checks, okay, is this production? If it is, then we build. Otherwise, we don't build. And that's why it said ignore build step. And to do that, you just go to your Vercel project settings. So I'll pick my project, go to the project settings, and then choose Git as the page. And here you can specify a build step that you can ignore. So that's how it works. So I'm just saying, okay, if it's production, then we exit one, which means we run the build step. Otherwise, we exit. So now I believe the deployment should be ready. Let's hope everything works as expected. So let's go to pull requests. It's still running. So let's see what happens in a little bit. Okay, all green. So all checks have passed. So we can see that our deploy preview has worked successfully. And you will see that we now have the Vercel preview URL and the neon branch got created. So if we go to the preview URL, let's see if everything works as expected. It should. And we have a different layout. So this is deployed. So log into comment, this is Vercel specific. You can leave comments on preview deployments, which is super cool. But now you can see that we have a different layout. And this is hosted on a different URL than production. If you want to go to production, this is the URL, and they're different. So this is like the before, and then there is the after. So mission accomplished. Now we have preview deployments that got automatically created, and these are full stack preview deployments. So they have data coming from the database, which is super cool. Now just to double check, we can see the branches. We can see that we have a branch that got created and it's active because, well, it's the one that we just created and it's running. And we can see the data in it. So if we go to tables, I'll select this newly created branch and it has all of our data, which is awesome. So that's it for the preview deployment. Now let's actually take a look at the deploy to production workflow. So for the deploy production workflow, this runs whenever we push a commit to the main branch. And the way it works is we have a step where we first check out, similar to the other workflow. We get the last commit SHA or SHA, and we're going to use it to find the branch that we just created as part of the preview deployment setup. And then we search the branch by name. So the way we do it is we do a curl command that lists all of the project's branches. So this is the URL. And the URL structure is /project/project ID/branches. And then we're filtering the response by trying to find the name, and the name should be the SHA of the pull request. Then we run Prisma Migrate. So this runs actually on the production database. And then again, we install the Vercel CLI, pull the environment variables, build a project, but now we deploy to production by specifying the -- prod branch. And then finally, we delete the Neon branch. So I actually just merged the pull request, which ran this flow, and you will see that everything ran successfully. So now you can see this job right here, and all of these steps just ran. So actually now if I go back to the console, I should see that I only have my main branch. And if that's the case, then mission accomplished. And if I go now to branches, I only have main, and we just cleaned up the branch. So now that we merged the change, if we actually go to the live website and refresh, we will see that the layout has changed, which is awesome. That's how you can achieve full stack preview deployments using Vercel, GitHub Actions, and Neon. Now, you can swap out Vercel with another deployment provider as long as they support the preview environment flow. Similarly, you can also use another tool other than GitHub Actions for your CI/CD workflows. And that's it. If you have any questions, feel free to reach out to us. And other than that, thank you so much for tuning in today, and we'll see you in the next one.